Hello, my name is Oleg Smolanko, and this is my presentation on my final project in the CSCI E-89 deep learning course, which was done on a churn case in the telecommunication industry. The problem statement is to predict the probability of a customer to churn in a telecommunication company with the help of a neural network implemented with Keras library. The analysis was done on a dataset from 2018, which was provided by my company. The dataset was previously anonymized. Technology used for the final project was mainly Anaconda Continuum, which comes with Python and Jupyter Notebook and some other helpful packages like Pandas or NumPy. In addition, I also installed packages like Seaborn or Keras. To do data inspection, I also use Notepad++. To start with, I didn't have a full dataset, but it came with 3 different ones, like base information, hotline contact information, and the usage data of the client. The base file consists of base information like age or birth year. Hotline file contains contact information with the call center, and the usage file contains information how many minutes the client talked in his own or other networks. All file formats were pipe separated. To start with, I installed Anaconda Continuum, and as mentioned, for data investigation I used Notepad++. In order to get a view on the data, this is the overview of the columns. As we can see in the base information, we have product information like type of the mobile phone the client uses or the manufacturer of the mobile phone, but it also has data like gender, birth year, or the resident of the client. Hotline base data contains information of the total number of calls to the call center and the total minutes he spent on the call with the call center. Usage data contains information of how many minutes the client spent in his own network, calling to other networks, calling to fixed line, international, or roaming. To start with, I imported the main packages, deactivated the scroll function when I plot many plots after each other, and I also imported the 3 dataset to Pandas data frames. In order to keep my code in the notebook short and simple, I defined 6 main functions which I use throughout the notebook. The first 2 help me to plot discrete and continuous variables after each other. The third one, concat dummies, helps me to append new hot and cold variable to the dataset. Cat categories function reduces the number of unique values in the column. And plot validation and plot accuracy was used when the final model was built. Starting with the base file, I pre-processed it. First, I set, for example, the column ID to index. For the birth year, I calculated backwards the age of the client. I replaced missing age with the median values. I normalized the age and dropped at last the birth year, as it is not needed anymore in the dataset. As we have seen, for example, the city column contains NaN values. I iterate through all discrete variables and replace none values with other. I print my result to see how many NaN values have been replaced in my dataset. If we take a look at the data, we can see the distribution of our discrete variable, for example, for the manufacturer or the gender. As we can see, Samsung and Apple are the most frequent used handsets. However, we have also a lot of no information about the mobile phone the client uses. We are also missing some information on the gender for some of the clients. If we look at the age, we can see the distribution. As applied in the code before, in the graph below, I normalize the data to use it in the Keras model later. We also, for the discrete variables, we need to hot encode them. However, if we look at the product column, we have 2144 values. And it comes that, for example, one model of the mobile phone appears only one time in the dataset. Building that column is probably meaningless for the model. As I mentioned before, I define a function which helps me to reduce the number of unique values in the respective column. This was used with categories. I either use 70% of the data in that column, or I use maximum 100 values. As we can see below, when I print my result, I can see that, for example, for product, I used 42 values and reached 70% of my data. For manufacturer, it is less than 100 unique values, and all features of that columns were dummied. However, if we look, for example, at the zip code, I used maximum 100 values. However, I only reach a cumulative percentage of only 8%. For the hotline file, we have, as mentioned before, only two columns. In that case, I set my column ID to the index, and in addition, I calculate average call duration. If we look now about the distribution of the columns, we can see that there are a lot of calls which are probably 1, 2, or 3, but very few which are greater than that. The same comes for the total minutes spent on the phone. We have mainly calls which are very less in time. However, if we build an average, we can see that the distribution becomes more clearer, which we can use in the data set. In addition, I also derive some variable whether the client spent the number on the phone was greater than the average in the data set. With that, I want to track very unhappy clients which spend a lot of time on the call with the call center. Having a look on the usage file, we can see that there are 5 columns of minutes spent in the own network, minutes called to other network, minutes called to fixed line, international, or roaming. What I do first is I format these columns to float, and in addition, what I want to do is to calculate the proportion of each column to the total minutes spent. Looking at that, we can see that, for example, total minutes spent in our own network is very few. However, if we calculate the proportion of the minutes total, we can see a much clearer distribution. Finally, I want to normalize it. However, it doesn't work for non-values. We have 34 out of 300,000 missing values. Therefore, I will deselect them. I will replace zeros with a very small number. I use lock to transform, and I normalize the data. As we can see, we get a much clearer distribution of my columns, which I can use in my analysis. To start with the analysis, I first merge the data, and I replace all the non-values with -1 in all the columns I derived in those data sets. I split the training in data set in 70-20-10 ratio, so 70% will be my training, 20% will be my validation, and 10% will be my unseen data, which I finally test my model on. To start with, I randomly shuffle my data set, and I export the churn flag, so the churn column, in order not to put into the model. And I split into training, test, and validate. Then I create my training model. This consists of 3 layers. So the first one is 128 neurons, 64, 16, and this is my final layer where I use my sigmoid function on. I use binary cross entropy as I only have output of 0 or 1. And I finally test my accuracy on my model on the test data set. I define this model in a function, so I can always call that in order to rewrite it every time. Finally, I run the model and I get the following results. Keeping in mind this was done with the default values, and the default values for the function were that no regularization was used. Which we can see basically here, that regularization in the regularizer was set to 0. I plot my validation and training loss, and as we can see, as expected, it starts to overfit quite quickly. My accuracy also starts to decelerate at the end, which gives a hint that we need to regularize our model. Therefore, we will run it with a regularization factor of 0.001. And what we can see now in the training and validation, that it does not overfit anymore as before. However, we can see that the training and validation accuracy is very stable, and it hits its peak quite quick, and I reach a high accuracy of 92.7%. I also implemented a much deeper model with more layers to see what happens. I run it also with a regularization factor of 0.001. We can see that the validation and training loss remain quite stable. And again, we have very continuous accuracy of 92.7%, which didn't really improve. And if we test it on our data, we can see that it reaches 92.7% as well. To summarize, I used 3 different data sets to build my final data frame. I pre-processed all the columns and made them ready to use in Keras, like deriving new variables, normalize them, and with 2 models I showed that the high accuracy can be reached quite quickly. What I learned from that project is that how to prepare different data sets, how to visualize them, and how to inspect different columns and to manipulate them. I also wrote quite interesting functions which made my life more easier. However, in analysis, it is strange that the accuracy level is reached so quickly. Although the data set is quite large and has different columns, I'm still wondering how this is possible. I shuffled it again and again in the background, but I came always to the same result. And this needs more investigation, which I'll take care of it after the course. Many thanks for your attention, and goodbye.